Okay, so you're asking about the actual setup. Over here we have a signal analyzer that goes up to 22 gigahertz. That set me back $1,000. This is the signal generator. I think it was at like $300 or $200. The traveling wave tube amplifier, like I told you, it ended up being free. This is from my hybrid battery business. This is, I don't know, $5, something like that. It's basically a shunt that we ended up shunting a little bit more. Jeremiah actually helped me with the DC power supply. We had to change out the pots in the front because we really just care about the current control, which is why we have the shunt, you know, to measure the current, because we're powering an electromagnet, which is on the other side of the wall, that is doing the laminar magnetic field, and it's important to keep the magnetic field exactly the same strength so that the alarm morph frequency is hit. You see all these holes in the wall? This is good. Change the light. Those holes go into a Faraday cage, which is on the other side. When we turn on the experiment, we have the on and off switch over here. This turns on an alarm on the other side. And this is our Faraday cage. Like I said, it's the size of a room. And the alarm switch to tell us it's powered up, but it's not powered up right now. This Faraday cage is one of the first things we built when I decided to do these experiments, you know, in higher power and try stuff for real. There's a grounding rod in the center that goes down 8 feet, and 1/4-inch aluminum panel, which connects to an inner seal, and then there's an outer seal that goes to a separate ground. And I'm not going to go too far into the cage because I probably will lose signal at some point. Let me see if I could make it into here.
Mark, I used to work for Bendix when I was putting together a hardware in a loop lab, and we were concerned about stopping the signals from Teterboro Airport. So we had to make sure these things were really closed up. And I see with the holes, are you filling those holes up and around the enclosures for electrical power?
Oh yeah, for EM pulses. Yeah, of course we have caps on it. So over here is the actual test apparatus, and the first thing we noticed is that the scale is affected by microwave energy. So we had to shield the hell out of it. It's literally covered with several different layers of aluminum over there, with grounding cables. And Tom, one of our scientists who shows up here sometimes, actually suggested to get a ribbon grounding rod that goes straight down, which I think is a great idea. We're going to try that for next time. But we were able to remove the noise during our null tests. There was some considerable noise before we were able to remove it. So it's very important that the scale be grounded if you're using a piezoelectric scale. I also got a mechanical scale, which won't be affected by RF, but that scale has it's extremely sensitive. So we wouldn't be able to measure full weight loss. We'd be able to measure if there was X amount of weight loss plus or minus. You wouldn't want to be inside this chamber while any of these experiments were going on. We tried using a mesh Faraday cage, and both a mesh around us and around the test subject, and we were just getting headaches. So we decided to move the entire experiment inside here. Basically, this is our electromagnet, and as Jeremy calls it, it's the EPR NMR laminar spintronic alignment rig. So over here we have a, this is where the test sample is, and it's basically a 3D printed setup that allows it to slide pretty smoothly up and down. This test subject is put in there. We have a whole bunch of different types of test subjects that we plan to try based on all different theories. Back over there we have a Yagi antenna for the signal analyzer, so we could see actually what's coming out. There's also a capacitor to smooth things out for the for the power supply. And behind this, this is a salt tank, which basically acts as a load, so that there's less reflected energy. In the future, I plan, basically we're going to make like a fish tank kind of device out of wood that's going to go across this entire back wall over here. And we're going to fill that up with salt water for the more high power experiments. I think that's an important feature, because you don't want the microwaves coming back and hitting the sample at a different angle and screwing things up. What else? So we plan on making the electromagnet possibly larger, because the space in there is too small for a 6 gigahertz waveguide, which is another issue. So we're going to have to get a lot more iron in order to work that out. And I was just having a conversation.
You can use a 3 gigahertz though, 2 to 3 gigahertz. The RB47 numbers.
No, we're going down to 6 because that's what's available. Basically, the lower in the frequency you go, the weaker the magnetic field needs to be, but it still needs to be very homogeneous. So
we just got a 6.2 gigahertz series of waveguides for free, and then he had purchased a Thyratron for that as well. But that's a good observation and thing to point out, because I wasn't even aware of that case being the inspiration for Alzafon's theory. That's news to me, so it definitely should be worthwhile to try that if that's what
Focus on it. Focus on it.
We will focus on it, and I expect that a full-size craft would probably go in that frequency. But the effect is the same no matter the frequency. You just need stronger magnetic fields. That's the only difference. And for a full-size craft, yeah, we would go with 3 gigahertz probably, because you don't want to be sitting inside of a half a Tesla field. You want it to be, it's 28.025 gigahertz per Tesla for, I think, the valence electron in aluminum. Me and Wayne and this guy Pablo, who works in an NMR company, we're going back and forth about affecting the other electrons, the deeper second, third, fourth, fifth row, depending on the material you're dealing with. And there are different or more frequencies for different electrons. And if anyone has any paperwork on that, that just shows all of the elements and their isotopes and the different or more frequencies in relation to Tesla, that would be something very useful.
Well, the reason I mention this is if people look at UFOs and they're 100 feet away from them, they turn on the radio and it doesn't work. Now you can stop a radio from using 5 watts, but they change the frequency and they're all off the air. So this damn thing, it's 100, 200 feet away. That's got at least a megawatt of electrical field. The bad part about all this is nobody can tell you what the magnetic field is. So you might want to look at this from higher values rather than lower values. But, if you can make it work with lower values, God bless you.
I mean, that's the goal. We can only work with what we have. And right now, the universe gave us waveguides that are actually tuned to a very specific frequency. So I got to, the theory should be the same based on, it's just a combination between a homogeneous magnetic field and microwaves. And if we could stick to one microwave band, a frequency, then we could just dial the electromagnet up and down, and we'll have to figure out how to make that dial as accurate as possible. And eventually we'll hit the dynamic nuclear orientation state, at which we'll be able to determine whether something happened or not.
Another thing I just wanted to point out, Paul, is that there's no clear indication that radio interference is actually part of the propulsion system itself. That could just be, they could just be shutting off your radio to prevent you from being able to communicate as well. I'm thinking, because 200 feet away, that's got to be far field effects. And from my theory on these skin coatings and the materials that they use is that they recycle all the electromagnetic fields with the near field. and that there aren't really a lot of far field effect, like the far field effects are minimized.
Well, let me go a step further by simply saying, I asked you this earlier, and I don't know if I got a response. Are you aware of the Paul Potter concepts?
That's the onion drive craft, right? Where they ionize the air and pull it, right?
Well, what is he talking about? He's talking about 3 balls that are rotating, 3 or 4 balls that apparently act like a magnetic field. There's a ring in there, so you have like an electromagnetic field that you see with the ARV. And then with all this crap is going on, which indicates one thing, that ET knows his electrodynamics down pat, they're throwing in some microwaves. So you're dealing with all these magnetic fields, electric fields, and you're throwing in microwaves just for the what? So you have
dynamic nuclear orientation. That's why you're throwing in microwaves. You're trying to make the craft weightless so that you need less thrust, which can be brought about by other means. Is anyone religious over here?
All right.
My takeaway from the Bible is
yeah,
why.
go ahead, let's hear it.
Okay, just one short thing. My takeaway from the Bible is, why did God need rocket thrusters to land at Mount Sinai?
What? I give up.
He didn't.
So anyways, I was getting a little cramped over there inside the Faraday cage, but there's also an isolator, and then there's a waveguide, and then there's a 3D printed wave horn, which is, these are all things that we're kind of confused about. I don't have too much experience, building waveguides. So if any of you know somebody who has some sort of knowledge in that field, that'd be very useful.
This is my 3D printed horn.
Yes, Wayne.
I don't know if that works or not, but I tried to design one off of a Wikipedia article about microwave horns.
All right,
So,
you really need a signal generator so you could see what actually is happening.
Yeah, and a spectrum analyzer too, right?
Spectrum analyzer, that's what I meant. Yeah, a spectrum analyzer to see what's going on. A signal analyzer.
So I got this. You were talking before about coming across things in just a timely way, and this is part of that marine radar thing I picked up at the side of the road. I mean, who leaves a marine radar out on the lawn? I mean, it's kind of unusual. I'm like, that's for my Elzaphon experiment. There we go. Thank you, God. So
maybe there is a law of attraction, Mark.
Yes, there definitely is a law of attraction. If you think about it, what you think about, you bring about. It's that simple.
I don't see any supermodels around.
Been around for a long time. The idea of actually putting your human efforts towards a single goal is certainly a powerful idea, but there's no need to bring in any kind of superficial or metaphorical or supernatural ideas into it. Quite frankly, it's just a matter of the fact that your actual actions create the real opportunities that you experience. And it doesn't need to be more complicated than that, really. I mean, it's deterministic, basically.
Okay. Yeah, so moving forward, I have to fix this power supply behind me and hook it up to the Klystron in order to try the Elzaphon experiment at a higher power. And I got some waveguides over here, a whole bunch of pieces that Jeremy picked up at that yard sale. And it's really equipment that we need, but you mentioned money. Somebody actually recently donated, some Bitcoin to help out. And yeah, money is great, but really what you need is equipment. You need equipment and time. Money is just a number.
I had a conversation with that anonymous donor last night too. I want to go over that a little bit, Mark, because he said that one of the things he pointed out was that we have to become self-funded. He can only donate so much and for so long. You know what I mean? We need to, at some point, we need to have a product and sell that and become kind of self-funding to kind of keep this going. You know what I mean? That's sort of we talk about immediate goals and long-term goals, short-term goals. I think our short-term goal should be find a way that we can make some kind of product and become self-funding, and find some way to fund the lab. We have enough smart guys here. I know we've discussed a lot. I won't discuss all our intellectual property here, but we've come up with a lot of good ideas for inventions of just things we can build and sell on our websites.
Let me give you some advice for all it's worth. Okay, let's say you come out with something great, game-changing technology, and it works, and you validate it. And then what you should do then is keep your mouth shut, build the piece of hardware, and when you're ready to get it going and sell it, then you go get your patents. Okay?
I couldn't disagree more. I think what you have to do is go on this chat group and show everybody else how it's done, and just let the world change on its own. Because like, you can't be greedy. You can't be asked.
We've had this discussion, me and Mark, and we believe that other people have discovered this before. And when you go to get the patents, that's when they get you, because you haven't told anyone yet.
Well, let me give you another example. One country used to rip off our technology. And while we were developing that technology for weapons, they were able to take our ripped off technology operational faster than ours. So you don't want to have the attitude where you want to build something and you got a concept and somebody rips off your concept and they build it before you do.
I would just send in my resume and ask to work with them. I mean, that's what I would do. I just want to build the darn thing.
I think what we're doing, and I believe in this, is that we're building a community through our YouTube channels and stuff like that. And so building this community, and when we stumble across something that actually works, or we discover the principle or the secret, the ingredient, then what I'd like to see happen is to teach as many people as we can how to replicate it. Because until we overcome that initial skepticism, there's no market for this. There's no money in it. So skeptics have to be able to have the recipe to replicate it and build it. And just like Michael Faraday discovered the relationship between electricity and magnetism, and how you could have a magnetic field around a current carrying wire. And then, so he discovered the basic principles. So I'd like to see those basic principles be discovered, and then share those principles, and then all of the business applications, all of the technology, all the different embodiments, which mean getting patents, right? Because you're now developing business, but I think that would come later once we get over the initial.
Well, it's nice to be gratuitous and generous to the rest of the world. But let me give you another suggestion. If you put together all the pesos, you can make a bigger thing, whatever you're going to make. And that can have a bigger benefit rather than putting it in your pocket. But you want to be in control of it because you know what the hell you're doing.
I don't want to be in control of it. I want it to be to go out to the masses. These are people, the Wright brothers were people who tried to control it. They actually got a patent on ailerons. And we all know you can't build an airplane without ailerons. And where did that leave the United States? At a severe disadvantage going into World War I. And one of the Wright brothers actually suffered a heart attack based on the lawsuits that they were fighting this motorcycle company, Curtiss, I think. It was all over ego. So I think the main problem in this field is there's, people get into their specific theory or something like that, and they're too fixated on it, and they can't see themselves possibly being wrong. So it becomes hard to work together. I'm trying to overcome that by just sharing everything. You know, I have no specific agenda toward any one technology. I'm just excited about whatever I'm trying, because you got to be passionate about it. You got to think about what you're working on, which is one of the reasons why all these other concepts that you guys are talking about, I'm not necessarily even that learned in it. I think Jerimiah and Tim are very learned on all these other theories, but the one that I'm trying, we try to stick to, and I don't agree with the whole patenting thing. You can patent it way down the line. I think the industry is so big that nobody needs to be worried about, you know, getting hired in making this stuff happen.
Well, the question here is, you know, you said you'd rather join that company. Why not make your own company? But then, you know, it's a question of your leadership capability and your management capability. And okay, I'm sorry.
I don't want to be the manager. I don't want to be the manager. I would prefer to find a professional. If I were to start my own business, me and Jerimiah would like to be like the chief engineers, but I wouldn't want to be managing the business on a day-to-day operational scale.
Well, Mark, what I've learned in life is that if you want to lead a company, you got to do it in management, introduce your ego into the direction of the company. And by saying that, I don't mean ego in a negative fashion. By an ego, I mean your ideas and where you're headed.
Oh, my vision, yeah.
Yeah. So, you know, people have done it differently. You can talk about Tesla himself, and you can look at Edison and the other opposite, where it turns into General Electric. But, you know, that's your preference. And I just, like I said, I'm sorry for interrupting everybody else in the audience, because I just want to get some sort of calibration of where this is going and what happens after it's done.
Well, after it's done, we're going to try to get the word out there as quickly and as publicly as possible, and you know, bring about anti-gravity disclosure, showing everybody how it's done. And it might be a combination of several things, and I truly believe there's more than one way to do this. So I'm not discounting anybody's idea. I love every idea that I could try in the lab. If you got a theory out there that has no application to a laboratory, I'm not interested at all. And that's really, you know, where we're trying to differ from the SD Spark conference, which I was at. They're trying to push the thing toward wormholes. And like, have we ever even seen a wormhole? Like, it's insane. I prefer to go towards the engineerable side, because that is what's going to change humanity, and that's what's going to bring about anti-gravity disclosure, and, you know, finding the real thing.
You know, and if I could jump in, you know, I should apologize. I kind of came halfway into this, but, you know, like pretty much everything that I ever did in this area is all open, you know, and Paul has done so much that's open also. Now, like with Morningstar, right? That was Paul. That's your guys' intellectual property, and I think you have a couple others that are IP as well. But then when you step back from that and think about how many scientific papers have you written, reviewed, peer reviewed, all of that stuff, and those are all public. So really, you know, all of us are kind of doing open source, and I tend to agree with what Mark said a while ago. Of there have been dozens, maybe hundreds of companies, right? Like, I mean, everything from magnet motors to free energy to anti-gravity, where somebody feels that they found something, and then the potential for money and the egos and all of that, it just tears things apart, you know? So in a weird way, the open source approach to it seems like maybe that's a path around it. And I know it has some dangers, right? Because then somebody could take your idea and run away with it. But then on the other side, you know, it helps. And then I also think that we're kind of getting into things that are too big for one person, right? And it helps to be able to share. I mean, so I tend to go with that. I see Jeremy making hand motions.
Well, you know, in Morningstar, the three of us must have put out about 30 or 40 technical papers in 10 years. But let me go back to an earlier comment made. What I see is that if you're a physicist, these guys are coming out with ideas, great ideas about anti-gravity. And Jack Sarfetti, for example, I say, hey, great idea, Jack. Sounds fantastic, but I'm an engineer. Can you build it? And the response is,